Okay, so let's start. The way I learned to do KMAPs was to kind of speed run it. So I'll teach you guys how to speed run it, so you guys will know how to do it fast. So the ways I was taught how to do it, you skip the third. So you draw, let's say you have 4 inputs, X, Y, X, Y, W, Z. These 4 inputs, let me see if I'm matching here so I can draw the same thing, W, X, Y, and Z. So you put them like this. You first draw a square. Let me see if I'm having it right. X, W, W, X actually. Y, Z. So you skip the third. So you count in binary, 0, 0, 0, 1, and you skip the third. 1, 0, 1, 1. Same here. 0, 0, 1, 0, skip the third. Whoops. 0, 1, 1, 0, 1, 1. So this way you just skip the third and you always end up doing the entire Karnaugh map at once. So, and it's fast. So you don't have to memorize what you're doing. So after you do this, you have to have the formula. You need to simplify. Let me copy this, probably going to be easier.
That's the formula, right?
Huh?
That's the formula?
Yeah, this is the formula we want to simplify. So we wanted to make it simpler. So we would like to know, how can we make this a more simple formula rather than have this big thing? Because some things here could be redundant. Some inputs could be just, we could just ignore them. So the way you do this, you look at the inputs and you look what they mean over here. So for example, this over here, this entire thing over here is, let me show you. The way you populate the kernel map, you look what at each of these ones over here, each of the, how do you call these things? Terms.
The bars?
I would call them not. So
Yeah, they're not.
W naught, X naught, Y naught, Z naught. He calls them W
Or just
bar.
Y bar, yeah.
But it's technically not because it's the opposite of.
Yeah, using bar and not is interchangeable.
Yeah.
You mean the same thing.
Okay, so we need to write down these terms down over here where the map is. So for example, when we draw the map, we need to remember that these over here, they have each one of these, they mean each letter. For example, this over here, this map over here, this is a 1 and this is a 1. This represents Z. So over here, Z is true. Over here, this is a 1, this is a 1. This is X. This is where X is true. Are you guys following?
So wherever there's a 1, that's where X or Z is true.
Yes, there's a 1 here and here. That's where Z is true because here Z is here. Do you see that?
Okay, I see that.
Same here. This is a 1, this is a 1. Okay. This over here is where, wait a minute, I think I made a mistake. Yep. Oh no, I didn't.
No, you're good.
I'm just seeing something else. This over here is where W, you see W over here?
Yes.
W is true over here and over here. So this over here is W, okay? Does that make sense?
E.
Same thing over here. So This over here is where y is true. So y is true over here and over here. So
1110.
no, just the y. You see the y?
Okay.
Let me draw on the other side so it makes clearer. This is w. And this is y. So the y over here. So each position, this is a pair, okay? This over here is a pair, okay? Does it make sense?
Mhm.
So each pair over here represents the values of each of those pairs, okay? So this over here, y over here is true and over here is true. So this over here is y, okay? Does that
Okay.
make sense? So this is the mapping of x, w, y, and z. And then this means that this over here, the opposite direction. You see the 0 and 0 over here?
Yes, the 0 and 0.
So this over here is w naught. This over here, 0 and 0. This is y naught. Over here, x naught. And over here, the same thing, z naught. You see that?
Yeah.
Now, all you have to do is just populate this over here on the map. Where you see z naught, you just draw a 1 over there. So for example, w naught over here. This entire column over here is w naught. Where w naught and then x naught. This over here is x naught and this over here is x naught. We don't include the bottom one because the bottom one is not included in the end. So we don't include the bottom one. Let me use a marker. So we want only the things that are inside of here. So we want x naught. So this bottom one gets eliminated. And then we want now y naught. So this side over here gets eliminated. So we were only left with this side. And now we want z naught. Z naught. Okay. Does it make sense?
Mm-hmm.
Now here is a 1. Same thing on the other side. X, w, x, y, z. Same thing. Would be over here, but then it's on the z positive. The z is positive over here. Okay. Same thing for the next term. The next term is everything's negative. W, x, except the y. So the y positive is over here.
So would it be like 1, 0? Oh, never mind. Yeah, that's right.
Yep. So this is y positive, and then everything else is negative. And then w is negative. W is negative. W is negative, and then x is positive. X positive.
X and Y is positive.
Yeah, x and y is positive. W is negative, and then z is negative. There's one here. And then W positive. I hate having a small screen.
Wait, so for W, X, Y, Z, where X and Y are positive, wouldn't that be like 0, 1, 1, 0?
Which one?
For the W, X, Y, and Z, where X, Y are positive,
This
wouldn't
one?
that be like 0, 1, 1, 0?
Where? 0, 1, 0, where?
0, 1, 1. I can't just point it, but
I think you can annotate.
it's the one all the way to the right, but like below that one.
This one over here?
Yeah, isn't that it?
Let me see. So
0,
negative,
1, 1, 0.
yeah, negative W, negative
X,
W,
Y,
X,
X, Y, and Z.
Y, and not Z, not Z. Yep, that's the one.
Non-Z. Yeah, okay, that's it. Okay, I
You
got
got
that.
it. And then the next one, X, you see that there's redundant terms. You just identify one. So,
Yeah.
and then W positive, X negative, W positive, X negative,
And Z is negative, right?
Z negative, and then Y, Z
Plus
negative,
1, 0, 0, 0.
Z negative, and then Y is also negative. So over here,
That's 1, 0, 0, 0.
1, 0, 0, 0.
Yes.
So it's a 1, 0, 0, 0, And then the next one would be W, X, W,
It's W, so it's 1, 0, 0, 1.
1, 0, 0, 1, 1,
Yeah, because you know, X and Y are negative.
1, 0,
Are not. That's like 1, 0, 0, 1. It's like to the right of 1, 0.
And then 0, 1, like over here.
Yeah, right there. That's where it belongs.
Mhm.
See, this isn't so bad. You just got to know the rules. That's all.
Let me see if I get the same thing. Yep. Oh, we're missing one. There's one over here.
There's one more at the end. It's 1, 0, 1, 0.
Yep, this last one here. Yep. All right. So after this, all you have to do is you do the grouping. You know how to do the grouping, right?
No, I do not. Can we go over that?
Sure.
Pretend I don't know how to do anything.
All right. So after you do this, you have to do the grouping of the terms. So the way the map behaves, it behaves like it's continuous this way, like this, like repeating as if this square over here was on this side. So the way you do the grouping, you always have to group a power of 2. So you can group a 1, you can group a 1, 1, this is one group, this is another group, and then you can group a 1, 1, 1, 1, this is another group, and you can also, if you find something like this, you could also group 1, 1, 1, 1, 1, 1, 1, 1, 1, like a power of, I think, this is also a group. So after, you need to look up for all of those groups that are powers of 2. You can also do like a grouping of 1, 1, 1, 1 like this. It could also be like that. So over here, we have one group. We have one group over here. We could do like a grouping over here. So there's 1, 1. That's
Okay.
one group. We could do one grouping over here, but remember what I just told you, that this continues over here and it repeats itself. The map repeats itself. So these squares over here are like over here as well. So do you see that there's a group over here?
Mm-hmm.
So we can make over here a group doing like this. That's one group. Do you see that?
Oh yeah, I can see that. Because like you got 2 like and they match, so you can like basically make a group of 4 ones.
Exactly. And because it extends like this one is over here, right?
Yes, I see that.
And this one over here is also over here, right?
Mm-hmm.
This means that this one over here is also over here. This one over here. Do you see that?
Yes, I see that.
So if we make a group over here like that, it would look like this. We're making the group look like this. Do you see that?
Oh yeah, I see that.
That's one group as well. So that's the possible groups you can do with this map. Do you see that?
Mm-hmm.
Now we're gonna play a game. It's called treasure hunting, okay?
Okay.
The treasure you have to find is the group. The problem is that I have to tell you, I have to write down in the map where the treasure is, which is the group. Okay. And I have to tell you, I have to give you the coordinates for the map where the treasure is. This is one group, right?
Mm-hmm.
So we want to write down the coordinates for that group. So I could tell you that the coordinate for this group is on Y.
Mhm.
But there's a problem. Y is this entire thing. So that's not very useful. So we need to be more specific. We need to eliminate this part.
Okay.
To eliminate this part, we need to include that's also not W. Do you see that?
Not W. Okay.
Because it's in W over here. But the problem is that this over here is not what, it's Y and not W. So we need to be more specific. This group is also in not Z. Do you see not Z here?
Yes, I see that.
Also, oops. Is it Z not or not Z? I never know.
I don't know.
Z
Not
not.
Z.
It doesn't really make a difference.
Doesn't make a difference, but Z not normally.
All right. So we have Y, not W, and not Z. So this group is represented by this over here. Okay.
What about not Y? Why not?
Why not? Why not?
Because there's a one, like that's part of the group. Is it not part of the group? The one at the very edge.
This one?
Why not? It's a little bit down to the very left.
This one?
That one, yeah. Isn't that one part of the other ones?
Yeah, so once they can belong to multiple groups. It doesn't matter. What matters is that you map all the groups.
Okay.
I'm sorry. What matters is that you map all the ones.
Okay.
So we found one group, okay?
Yes.
Now we need to map the other groups, the other ones, the other treasures. So plus, we only have discovered this treasure. We need to find the others. So we have over here, one that's here.
Mhm.
One group like over here. This is one group, right?
Yes.
This one over here as well. So how do we map that one? We look for where they can relate. So whenever, one rule that I use is that whenever they cross the line with a group, they don't belong to the group. So this group over here is completely inside. It's completely inside not Z. Do you see here?
Mm-hmm.
So it's not Z. Or Z not, I don't know.
Yeah, it's not Z, Z not, same thing.
And then the same thing over here, it's completely inside X not. Do you see that? And then X not. And so if we have Z naught and X naught, yeah, I think that's it. Z naught and X naught.
Z naught, X naught. Because there's a one over at X naught.
Yeah, so these ones over here, they're over X naught. You see that?
Mm-hmm.
And this side over here is also X naught. You see that?
Yep.
So those are represented by this. Does that make sense?
Yep.
Right. So now we have, oops, most of them mapped, with exception for this one over here. Oh no. With the exception of this one over here and this one over here. Make sense?
Yep.
Those are the missing ones. So we have to map their group. So their group is over here and over here. So they're completely inside not Y, or Y not plus Y not. Y not's the whole thing. We need to exclude that. And that's X not.
So as long as we know, like, where Y not Y, W not W, Y Z, Z not X, and X not is, like, it's really easy to find where the ones are, because you can just like basically like make groups out of them.
Right. So let me see if I got it right. So WY not. So W Let's see. X and Z I got right. X and Z over here. W naught YZ. W naught YZ is over here. And the last one, Y naught X naught. Y naught. I got one wrong.
That's W Y, that's WY, not XY. So let's take a look. The W one here and then, well, yeah, it is in WY.
Let me see. I made one mistake. Oh no.
No, it's, I think it's WY. That's what it is. W, like W not Y not.
Can you annotate the screen?
Yeah, it's the last term you're, I believe. It's that one that's wrong, yeah.
Yeah, it's that one. It's supposed to be W not Y not.
W naught.
Yeah, so you have W naught right there, and then you have the Y naught. You notice how like it's like going, it's like the edge, the ones at the edge, and how they're connected.
Uh-huh.
Yeah, that's W naught Y naught.
W naught, which is this over here. And then Y naught.
Yeah.
Yep. Y naught. Yep. Why did I put X naught, right?
Yeah, it's, I mean, X naught is technically,
Oh no. Oh yeah. Yeah, my bad. You guys are correct. My
it's
bad.
technically, so X naught is right next to Y naught. That's probably why
Yeah, my
they're a
bad.
little confusing.
This over here is not included. I ended up including it. So yeah, that's how you build these things. What I never see people doing, in my opinion, this over here doing this is extremely useful to build the last part. So always include these things over here, so it makes easier for you to build the final part.
Yeah, where you like put in where the Z is, where the Y is, and stuff like that is very useful. That's how you figure out like where the grouping is.
Uh-huh. All right. So
Because it's just like, for example, WX, W is like the zeros like in at the left. So it's only true when there's like one at the left, right? Like that's why you have one and 1 0 is where W is true, because W is first, and X, the one, it's 0 1 1 1 is true because that's where X is true. If that makes sense. It's kind of hard to explain without me like pointing.
yeah,
But
I think you can point to the screen. There's
no,
an
I
option.
can't. Can I?
Yeah, it's called annotate.
Oh yeah, you
Dang,
can.
I don't know how to zoom stuff works.
Whoa, I didn't know you could do that.
I'm not seeing your
You
annotation.
learn
Yeah,
more
can you
here.
see that? That
Yeah, I
just
can
drew
see
that?
Uh-huh.
No, I
Okay.
think annotate only works for you though.
No, you can
Oh, it
draw
works.
anyone. You have to press on the view options, and then all the way on the bottom it says annotate.
So Charles, why
Yes.
why KMAP is a big deal? Because when we build circuits, we go from this huge thing to this smaller thing.
Yes, I see that.
There's like 5 or 6, 7 terms over here, and there's like only 3. So that's why it's a big deal.
Okay. Well, K-maps is not so hard anymore. Thank you for explaining this. Now
Yeah.
I know how to do the K-maps. I know how to like know which one's which based on whether it's 0 or 1. I know how to make the groups. And I know how to put the groups together based on just where the 1 is.
So always remember to look for the groups. And doesn't matter how you do the groups, you can do groups differently and you get a different answer, but that's fine. Sometimes that happens.
Another thing to point out,
do like don't cares and stuff, because like that was the part that always confused me when doing KMAPs.
Isn't
Was
that for
how do we know
the
when it's a
7th
0
segment
versus a
though?
don't care?
The don't
I'm not
care
sure, 'cause
only
I've seen it
matters
before.
about our circuitry. So if our circuitry calls for we don't care about this output for an LCD or for a pinout, then we put don't care. In terms of just this and basic knowledge of K mapping, it's fine. But yeah, if we have like an output that we don't need, that would be a don't care instance.
Yeah, because we spent a lot of time with those like 7-second stuffs, and I remember us doing stuff about like don't cares.
Yeah.
But how do we know when it's either a don't care versus a 0? Because that actually makes a difference when you're trying to make groups.
I just did it based off. Remember when we did the chart, the A, B, C, D, and E, F, like we did all of it, where it's like one
Yeah.
symbolized like if it was on at like A. Basically, just look at the little chart you make for it, and whichever ones are 0 are going to be 0 on your chart, and whichever ones are blank that it's neither 1 or 0, those are the don't cares.
We should probably do an example of this.
Yeah, sometimes you will find something like this.
Because
Okay.
this is not the first time that I've seen like don't cares K-maps and stuff, and I just don't remember how you determine the difference between a 0 and a don't care, because I know that when you make groups of that stuff, having don't cares can help you make extra groups, whereas having zeros will definitely stop you from doing that.
Yeah. So there's, for example, if we try to make groups over here, the two possible groups would be this one
Right.
and this
And
one.
the vertical one.
Okay. So those are the only possible groups.
Mhm.
Now, if this 0 over here, in fact, was a don't care, they're often represented by X. You could actually do a big group like this. So that's why they're important.
Okay, so we
Right.
include the don't care?
Yeah,
our
because you
group?
don't
Can,
Yes.
yeah. Don't cares are
You
can
only
use them
include
as
it
ones.
if it helps you simplify further.
Yeah.
If not, you leave
Yeah.
them be.
If there's a don't care here and a don't care here, you leave them alone.
Yeah.
Because
Actually, that would technically make another group, but that's besides the point.
Yeah, that would just
you do like one group.
overcomplicate it again.
Yeah.
Another thing that we should probably note is you may not always get your function form, and you instead might just get its truth table. So if he gave us this, for example, and then gave you the binary, you'd have to write that down in the same KMAP. So it technically still reads out the same as your function up here, but it doesn't work the exact same. You understand what I'm trying to say? Is he could give us this truth table with the zeros and ones, and you'd still plug it in like this, and then you'd...
Oh, okay, I get you.
Yeah, so he could do that. I know my my teacher that taught us these concepts in school where we would draw circuitry design, he would give us both randomly. So just food for thought. It's the same concept, but just different form for starting.
That's what I was going to do with the 7 segments, because 7 segments is almost the same thing.
Yeah.
With the same thing as KMAPs, but in other context. So do you guys feel good about this?
We're good on that, yeah.
Yeah.
I think so.
Let me go to 7 segments then. So also no idea about this? Let's see if I have to see.
Yeah, we should probably just review everything, just in case.
Assume nobody knows anything, and then when we go over this in video, it'll help whoever needs whatever.
I'll probably have to split
make
playheads from pre-spring break to now,
Look,
and then have two videos.
Just pretend everyone's as dumb as me when it comes to this class.
We have
Because I'm, like,
31
really
minutes in already.
Because I'm like really dumb in this class. Like ever since the midterm, like it's just been going downhill for me.
Yeah, you
Whatever
get lost in one
confidence-
concept, and it's like,
Whatever confidence I had in this class, it is gone.
So one thing that happens, this was what Riley was telling about, this thing over here. So you have this thing, and then you have to turn this into a KMAP.
hell.
So you have ever seen these clocks, right?
Yeah.
Yeah, those are 7
have-
segments.
This model. So each one of these has a different circuitry that goes on them. And each circuitry has this function over here to make them work, if that makes sense.
Yep.
So this over here represents, if I recall correctly, this represents the number. So we go from 0 up, all the way up to 9. Oops. And then you need to represent, you need to know what this over here tells you what's the segment that's turned on, so that this digit can be represented on the screen. Does that make sense?
Mm-hmm.
So for example, let's make one over here. A, B, C, D, E, F, G. So for 9 to be on, we need A, B, C on. So A, B, C on, F, G, F, G. That's a 9. That's a horrible 9, but it's a 9.
Yeah.
I wasn't gonna say nothing, but I was like, yeah, I get the point.
Yeah. This is way prettier than what I just draw over here. Let's do the same thing with the number 2. Oops. Whatever. So for the number 2, A, B, and then C, 0, D, E, F, and then G. That's the number 2, as over here.
Wait,
And
so
then,
number one, well, hold on, wait. So for number 1, would it just be B and C,
Mm-hmm.
or
Yep.
F
Yeah.
and E? Is it like to the left or the right?
It's
I
B
don't
and
know.
C. It's the
Yeah, to the
rightmost.
okay.
right.
Oh, okay, okay,
Technically doesn't matter, but in this course it's BC.
okay.
Okay, so there's that. Where Riley was saying, let's say we have a KMAP, and then it tells us that we need to input to know what is going to be the output for that number. So for example, over here, there's an example for what I'm saying. Each of these numbers so we speed run it 0 0 1 0, oops, 0 1 1 0 1 1, 0 0 0 1 1 0 1 1. So each of these numbers represent, let's say, B8 and B4 over here,
Mm-hmm.
8 and 4, and then 2 and 1 over here. So each of these numbers, the A over here, the A, B, C, D, E, F, G, maps what these other numbers are. So these numbers over here, let me draw another color. Use another color. So these numbers over here, Jesus, these over here goes over here, and these over here tells you what goes inside. Does it make sense?
Yes.
So for the number, for the letter, for the number 0, so 0 0 0 0, this is a 1. And then wait a minute. I'm doing something wrong. What am I doing wrong?
Wait, so we just put 1 for the 0, or?
Oh, I'm sorry. So this is over here. I'm sorry. That's what I just noticed I did wrong. It's not this. It's not this over here. It's this over here that goes in the KMAP.
Okay.
So 0 0 0 is a 1 over there, over here. And then for the 0 1,
Depends on your segment you're trying to light up.
Yeah.
So we're doing the A segment right now.
Uh-huh. So B1 over
You
here.
have to go one by one.
Mm-hmm. One over here, and then the rest false. So this is 0, and then the next one.
Dang,
2.
this sucks.
Yeah, it's hard.
That's
Yeah,
why
it's
I'm gonna like
horrendous.
during the if it's gonna be like before the exam, I'm just gonna have this chart already up because it's gonna save you a lot of time.
Yep.
It's
Yeah,
literally gonna be
probably.
multiple pages though, depending on what number you're trying to display on there. To have every single number simplified in the KMAP is kind of insane.
Yeah.
This should be
Hopefully
terrible. We'd have
just-
so many game apps.
Mm-hmm.
It would literally
Luckily,
take us like 2 pages to write everything.
Yeah, I feel like he's only gonna choose like a couple, like maybe like letters for us to do.
It would have to be a very, very, very simple number, if that.
so
Like, or he just picks
Like
one
one.
letter.
Like I don't like.
Like one.
I'm hoping,
Just
yeah.
something that's very simple if he's gonna do this much.
So when I had
Because
to
otherwise it
do,
would take up so much time and space that we just wouldn't have.
We can't turn it in if that's the case.
I had to do a 7-segment display for my birthday as an assignment in this one class, and thank God my birthday is 12/20/01.
Oh my god.
So I just copy pasted my circuitry and just like duplicated my actual ICs on my breadboard to get my output. But the poor people that had like, 0318,
Oh,
like
no.
I couldn't imagine having that many outputs because yeah, it's horrendous doing these things on that scale.
What class was this for?
It was actually in high school. It was called
Oh.
digital electronics, and we had a unit on K-mapping and 7-segs. So
Did
I
your teacher just like hate you or something?
no, this actually wasn't the worst of our projects. We covered flip-flops in that course.
Damn.
We were on the CMOS, so like actually programming on top of circuitry design. That shit was awful.
Wait, what language in programming?
God, I don't remember. I didn't get to the programming part. I had my physical logic done, but I didn't get through my software, so I don't even remember. There's probably Vex though.
Okay.
I don't know what Vex is. Is Vex the language or is Vex just the?
I don't remember. I remember I did robotics and we used that for.
Because I can't remember. I don't remember.
I don't know.
Because that was junior year. So. Plus
So-
that unit was during finals.
If one good thing to do, if he ever asks about this on the exam, is to do this. How can I say this? Pre-compute this, if that makes sense. Does it make sense to you guys?
Wait,
What?
wait. Yeah, sorry.
You guys see that I'm doing this over here for the 8, right?
Yeah.
Yeah.
And then we have to do this for this map for each of these, right?
Yeah.
Yeah.
Oh god.
If he asks us to do this on a test, we can pre-compute this. Does it make sense?
Oh yeah, I got you. I mean, you can already have like the tables for each one ready.
Yeah, the tables and the maps ready, so you don't have to. So you
That's
have more
true.
fun.
Yeah.
I'll probably do that once it's like.
You have like
Closer.
multiple papers, but
Yeah.
it'll help.
Yeah, for sure.
Yeah, I could see him doing like one numbered output. I don't see him doing more than that though, because that's a lot of time. Maybe that's why the test is so close, because this will take us like half the test to do.
Probably.
There's still 2 segments. Jeez.
This class is progressively getting harder, and I am not okay with that.
It's getting faster.
Yeah,
Yeah.
that's what's happening. Yeah, I felt like we had a lot more time for the first test, and then I was like, okay, now the next test is already here.
No, it like seems the lectures are moving faster. Like I don't know if it's just
Yeah.
me, but like I sat down today, I was writing down my notes. I looked at the time and we had like 10 minutes left,
Oh
and I'm
yeah,
like, what?
yeah, it did. I was just like, dang.
There's no more time.
So do you guys want to try to do the grouping for this on your own?
You
You
write
guys
it
can.
down.
If you guys can draw, you guys should try.
Oh, we can
Zero,
actually
zero,
annotate
zero,
on here, right?
zero.
We could try.
We could do it on the screen technically.
Yep.
Yeah, that's what I was thinking.
Let me try. How do I do it?
Wait, are all the other ones zeros? You made sure they're all zeros, right? And that some of them are don't cares.
Hold on, wait, where's the thing to draw on the thing?
If you click on view options and then annotate, you have to be out of full screen view.
I
Out
think
of full screen?
these ones over here are the don't cares, right?
Yeah.
Oh,
Hold
okay,
on.
okay.
Annotate, where is annotate? It
Hold
just
on.
says standard side by side, swap video and share screen, full screen.
Share screen, and then next to the right should be annotate.
Share screen?
And then to the right should be, don't click share screen. So to the right button to share
Go
screen.
to
should-
view options. It's the view options right next to like the green bar on top, and then
Oh, that view
the
option.
third option it says
Annotate.
annotate.
Okay, let me try. Here's the mouse, here's the draw. Okay. Hold on, wait, it's not letting me draw. Okay, what if that's one?
There you go. Let's go.
And then hold on. This is another one. This is another one. This is another one.
Hold on, Charles.
This is another one. Okay, I think that's it.
Hold on, Charles. So
Wait, shouldn't this be a zero here? Here, this one right here.
That's a zero.
0,
that be a zero?
0, 1, 0, 1. Nope. 0, 1, 0, 1.
Wait, I'm looking at number 4. Display
perfect.
4.
That's
0, 1, 0, 0.
0, 1, 0, 0. Yeah, that's a 0. You're right.
Hey, hold on. 0, 0, 0, 0. Making sure now.
Yeah, I was just checking the zeros. It's faster that way.
Everything else is right though.
Yeah, everything.
The
That's
question is
zero?
now, how do we erase this?
He has to erase it.
He has to erase it. Just press.
I can
erase
clear
it?
all. There you
Oh
go.
wait.
Nice.
There.
Charles.
Yes.
So you cannot do a group like this, and you cannot do a group of 3.
Oh, no groups of threes.
Yeah, you
It's
can.
got to be 2s, 4s, or 8s. Things like
Or
that. I think it's
16s
powers of
if you
2s.
get to 16, but
Okay, let me try again.
Yeah.
Yeah, and your groups sideways, you can do those as well.
I can do sideways or no?
You could do
No.
horizontal and vertical, but not diagonal.
Oh,
No
okay, okay, okay. Like that.
only time that's possible is 4 corners. Because technically it's not that way.
I think that's probably it. Yeah, I think that's it.
You're missing a 1.
I'm missing a one.
Yeah, the one in the top
Corner.
left that you have to include that
Yeah.
one.
Oh,
so.
oh. The heck I'm gonna group this one with though. There's no one
So
here.
if there's only one, you make its own group.
Oh, okay.
Okay.
Wait, that's
Yeah,
a thing. You can just.
I
put it
think
by
there's
itself?
better way to do this.
No.
Yeah, I was like, I
Yeah.
think you could probably. Can't you do the?
Oh, I know what I can do. Look, like this.
Because you doubled up on a group.
Yeah,
you
I
can do
saw
that.
that too.
Yep. There you go. So yeah, you have to do all these like little groups, even though overlapping over here, overlapping like you did. So you don't leave anyone behind. Anyone behind.
Yeah,
Leave
so
nobody
in the
behind.
case, because I saw one overlapping here with these two. So in the case of that, you would only do these two, like that.
Mhm.
The only time you would do something like that is if this was a 1 and 1, and this was a 0. That's the only time you have them intersecting like that. Normally they'll just be on their own. Does someone want to draw the actual grouping or?
Yeah, I'll do it.
Okay. because I don't know if I should have just done it or not.
Yeah, so this would be the one. I will use the one you draw, and then the one that Charles draws off. So there's one grouping over here. And then one over here.
Yeah, so just give you a total of 4 groupings.
And then we do the B's. Let me see. So we have B2, B1. B is 8 and B4. So this over here is B8. And then this over here is, I hate that I don't have space. Let me see if I can go to the side. Yep. And then this over here, true and true, this is B1. And then over here we have, B4. And then on the bottom, we have B2. And then this over here.
Oh, I was confused at first. I thought that 2 zeros were a 0 and a 1 for a second.
Yeah, I saw that too.
That confused me. Okay, I got
It's
it.
hard to draw.
No, you're good. Yeah, I was like looking at it like, why is that? Okay.
All right. And now we do the grouping. So to map this one over here, we have B1, they're inside B1. So this entire thing is B1. And then we need to exclude this part. So to exclude this part, we do B8. I'm sorry, not B8. So now we have this over here, oops. This over here. And then we have to exclude the top. So the top is this one over here, B4, because it's also over here. Do you guys see that?
Yeah.
So we exclude B4 by including this not before, but include the B4 over here. And B4. Does it make sense? Because it's.
I wish it gave us different labeling than the BE
Yeah, the
stuff.
B's is more complicated, yeah.
But yeah, that's the right thing.
That makes sense.
Before B8, what is that? Before B8? Before not B8?
B1.
It's B1? Oh, okay.
Why doesn't B4 have a bar on top?
B4, where?
Like, why doesn't B4 have a bar?
Because we're going for that middle grouping there. If you put a B naught, that's just getting the areas that are on the top and the bottom of the board.
Okay.
So what I was saying was that you exclude this one. To exclude, you need to not before. Not before is before. Does it make sense?
Yeah, okay.
Sometimes I think on reverse and I confuse people.
Yeah, you're just narrowing it down by picking stuff that's within the boundaries of it.
Yeah, for this grouping. So after a while, you get the gist of this. So this grouping is on this one and this one. Can you guys see that? So we have B2 and B8 plus B2. And then we have this entire thing. And then 8. I'm sorry, not B8. And then it's also inside
I hate how messy this gets.
Yes,
It's B4 not.
B for not. Yep, it's inside B for not.
You should have used like X, not W, X, Y, and Z or
Yeah,
something.
literally, yeah.
I used that one because he uses over here.
Yeah, I know it's so bad
Um,
though.
This is way too messy.
Yeah. And I think
Yeah, you
that's
could do this for like more than one.
This is only for one segment too.
Exactly.
you can do this more 8 times. 1, 2, 3, 4, 5, 6, 7, more 7 times.
Yeah, so
Wait, what if-
normally you would go for just one as an example because you only have to really worry about a couple, but it's so awful.
Wait, in a real world setting, what is this applied to?
7
So
segment displays,
Yeah.
yeah,
The clocks?
clocks, yeah,
Yeah, clocks.
mainly analog systems. So like think of like old arcade games like skee ball. You're throwing the skee, like you know what skee ball is, right?
Mm-hmm.
And it gives you a little score at the top before you get your tickets. Those scores
Yeah.
are in the same
7 segment.
7 segment displays. So that's another way you'd use them. Anything that
Damn.
uses 7 segs would be this stuff.
So like this stuff, like it's how you make the 7 segment stuff? Or
This is
Yeah.
how
like,
you light them up, yeah.
I'm glad I'm not making this.
Yeah, they're pretty awful. I wonder if I could find
Tedious.
my engineering notebook from when I had to make my birth date using these things. I probably still have it somewhere.
Oof.
Wonder if I could find my circuitry. The rat's nest. I kind of want to find it now.
And then are we gonna draw the circuits for these as well?
I don't think we have to, but it should be good. So this, I believe, entire thing should be segment 8. There's more 7 over here.
Yeah, the groupings together are going to be AND gates, and the pluses are OR gates.
Yeah. So this is something, I'll review this since it's something many people still have questions from last exam. So I'll draw it. So B1, B2, I'll just make them go like numbers 1, 2, 3, 4.
Yeah.
Yeah.
That's easier.
Ah.
I remember in the beginning of the semester, I was thinking, oh, this class might be fun. Halfway through,
So we have, I use powers of 2. So it's actually 1, 2, 4, and 8. So the first one over here, we have 1 is true, okay? 8 is negative, not 8. And then 4 is positive. So they all continue. And they're all ended. Is that the end gate? And then we have an OR. They're all ORed. And then OR. Let me see. 2 is positive. So 2 goes over here. 8 is negative. 8 is negated as well. And 4 is negated. So 4.
wait, this is how we draw the circuit?
Yes, but I'm getting messy for some reason. Let me check
They're
it
always
out.
messy.
Yeah. 1, 2, 4, 8. So 1 is true, 8 is negated, and 4 is not negated. And then 2 is true. This is an 8. 8 is negated. 4 is negated as well. And then another AND gate. So 2 is negated. 8 just goes through, and 4 is negated. And then the last one, 8 just goes through, 4 is negated, and 1 is negated. And then all of this goes over here. That's the A segment.